Guys, how you guys doing? This is Coach Scott here with Purple Wave Chemistry. So let's do another review real quick. Let's look real quick. I got my little calculator going. I got my little periodic table going. Hopefully you guys will appreciate that. Um, but we're looking at molecular formulas now and how they work. Okay, and so the rules for molecular formulas are very similar to empirical formulas. In fact, they're the same thing. You've got to find the empirical formula first in order for all this to happen, right? So how do we do that, right? So this is more like a review of the video on how to do empirical formula. So first, if you recall from the previous video, we have to, if we have grams, we've got to go into moles. Once we go into moles, then we have to make whole number ratios. Again, the empirical formula is the least whole ratio of a compound. Okay, that we have to uh, find the molar mass, the formula mass, if you would, of the empirical formula. Now, that's not necessarily the molecular formula mass. To get the molecular formula, um, we have to know the molar mass of the actual molecule. All right. And here we said that this compound of iron and oxygen, okay, is the molar mass of the molecule is 5 times as great as that of oxygen. So this particular problem, through another little issue, if you would, into our problem of okay, what's the uh, what's the mass of the molecule? Well, it says it's 5 times as great of oxygen, O2, oxygen gas. So let's get that first. You don't have to, but let's do it. So let's find the molecular mass. Mass. All right, so first we have to find out what the mass of O2 is. So you see up here we got oxygen. Oxygen by itself is 15.999, we'll use that, grams per mole. Well, it says we're using oxygen gas, which if you look here, it's O2. So O2 is 50.999 times 2, or 32, more or less. Let's do it. So let's see, 15.999, that's 1.999, 15.999 times 2. So that give me 31.998. 31 point. It says that it's 5 times as great as this mass. So let's multiply by 5. So that's going to be times 5. So the formula mass, or the molecular molar mass, is going to be around 159.99 grams per mole. Okay, we found that. Usually on these problems, they'll give you what it is. And if you're in real life, you're going to have to use an instrument, mass spec or whatever, to find what the mass of the compound actually is. Okay, so now they gave me that the mass of iron oxide, we'll use red for iron, red for iron, is 1.16 grams of iron. So that's Fe. It says it's 1.116 grams. Okay. Gave me oxygen is 0. Sorry about that. 0.480. Oxygen is 0.480 grams. Okay, so I got my mass of that actual issue. So now I've got to find the molar mass. So I'm going to go up here to iron. And this periodic table tells me that the iron, the molar mass for that, is 55.845 grams per mole. So, um, moles, because that's what I want to find out, how many moles it is. So that means my grams is going to go on bottom. So I'm more or less going to divide mass in grams to get the number of moles. Let's do that real quick. 1.1. Here we go. 6 divided by 55. I've got 0.0199. I'm going to call that 0.020 moles. Okay? So I got to do the same thing with the oxygen. So the oxygen, okay, we're going to multiply 1 mole mass of oxygen, 15.999 grams. So essentially what I'm doing is divided by the molar mass of oxygen. Let's do that real quick. Let's see, 0.48 divided by 15.999. And I got 0.030. Okay, so I've got Fe got the moles. So now I'm going to divide through, and I'm going to use purple for this, by the least number of moles. So iron in this compound has 0.020 moles. Oxygen has 0.030 moles. So which one has the least number of moles? That would be the iron. So I'm going to divide through that by that. And that's going to give me 1, okay, as a whole number. Divide 0.030 moles of oxygen to get the least number by 0.002, 0.0020. And that's going to give me, we'll do it over here, 0.03 divided 0.02. That gave me 1.5. So 1.5 is not a whole number. I can't have half an atom, so I've got to get that to a whole number. I can't really round because that's too far away from 2, and it's too far away from 1. So I've got to figure out 1.5. I know if I multiply that by 2, I get 3. Okay? So if I multiply that by 2, that means I've got to multiply this by 2. So what does that mean? That means I have 2 atoms of iron, and I have 3 atoms of oxygen. So I could draw that in a picture form of 1, 2, and then oxygen. Okay? That would be the empirical formula. It's the least whole number ratio, okay? 2 and 3, that's the least whole number ratio. So now we've got to see if that's the molecular formula or what the molecular formula is. So I calculated that the molecular formula is 159.99. Okay, so now I've got to get the empirical formula mass. So how do I do that? Okay, I know the molar mass of iron is 55.845. I have 2 of those in the empirical formula. So we'll figure out what that is. So oxygen, in what I calculated is the empirical formula, okay, the molar mass of oxygen is 15.99. Says I have 3 in the empirical formula. So we have to calculate the mass of that. So let's do that real quick. 55.845 times 2 gives me a mass of, and we'll go to black, 68 grams. Okay, not grams per mole now, it's grams. Okay, so oxygen would be 15.999 times 3. Gives me 47.97 grams. So let's see what that total is. I bet you it's going to be pretty close to 159.99 grams. Let's see. Answer plus 111.68 gives me 159.677. Now I calculated the molar mass, what they gave me is 159.99. So this is what we would normally do, especially that this is close enough that I can tell you that the molecular mass of FeO3 is Fe2O3. But if I was to do the ratio, 159.99, that's the given or calculated molecular molar mass, divided by the empirical formula mass, 159.677. Let's do that real quick. 59.999 divided by 159.677. I got 1.00. That's my factor, 1.00. Make sure y'all can see that. I don't have to multiply across the empirical formula by anything. So that's done. Let's look one more real quick, and we'll go quick with this one. So with this one, I've got a compound that has 7.2 grams of carbon, 20 grams. It's got 1.2 grams of hydrogen, and it has 9.6 grams of oxygen. This is the more traditional formula you'll see. Now notice it says the molar mass of the compound, the molecular mass, is 180 grams per mole. Okay, so we need to find the empirical formula, and we need to find the molecular formula. So how do we do the empirical formula? We've got to get things to moles. So I've got to more or less divide my mass of carbon by the empirical formula, or the molar mass of carbon. And if you look right there, it's 12.011 grams for every 1 mole. Hydrogen is 1 point in this periodic table. Oh, my fault. 0.008 grams. And then oxygen is 9.6 grams times 1 mole. And we should know that from our other problem, but it's 15.99 grams. Okay, let's do our calculations. Okay, so 7.2 divided by 12.0111. That's not right. 7.2 divided by 12.011 is 0.59, or let's go ahead and get close, 0.60. Okay, let's see, hydrogen, 1.20 divided by 1.008. Got 1.19, or we can just pretty much say 1.2. Okay, now let's do oxygen. 9.6 divided by 15.999 and 0.60. These are moles. So my next step, I've got to find my least number of moles. Looking right here, it's going to be, well, either one of those. It's 0.60. So now I'm going to divide all these by the least number of moles, 0.600. That's going to give me 1. That's going to be 0.600. And if you want to see it, 1.2 divided by 0.6, but it's 2. 2. And then, of course, that divided by 0.600 is going to be 1. So that gave me my empirical formula. So I'm going to have carbon 1, hydrogen 2, oxygen 1. Empirical formula. I'm done. Okay. So I would, if I was to see a little diagram of that, okay, I'm going to because you need more space. Do it like that. I'd have 1 ball of carbon. I'd have 2 balls of hydrogen. and 1 ball of oxygen. So it's 2 blue balls, 1 black ball, and 1 red ball. Okay. So that would be a diagram. So I'd say that was CH2O. Okay, now let's get the molecular formula. Okay, and how do we do that? Well, first, they told me what the grams per mole was of the molecular formula, 180 grams per mole. So what I've got to do first is calculate the empirical formula molar mass. So I know what my number of carbons is 12. So I've got 1 carbon, 1 times 12.011. Hydrogen, I know what that is. I've got 2 times what? 1.008, whatever that is. Oxygen, I have 1 times 15.999. All right, so that tells me that I have 12.011 grams. I've got 2 times 1.008, 2.0106 grams, and 15.999 grams. All right, so let's add that up. 15.999 plus 2.016 plus 12.011, and I got 27.026 grams per mole. For every 1 mole of CH2O, it would be 27.026. So now, what I'm going to do, I've got the molar mass of the empirical formula. I know because it was given that the molecular mass of the molecule is 180 grams. So I'm going to divide through by the empirical formula, call that EF, empirical formula in the molar mass, 27.026 grams. Let's do that real quick. 180 divided by 27.026. Did I do that right? 29. 011 plus 2.016 plus 15. 30.026. So that's incorrect. I knew something didn't look right. 30.026. 30.026 grams per mole. Let's try that again. So I got 180 divided by 30.026, and a factor of 5.99, or what is that really? It's 6. 6. So what does that mean? So that means I have to take the 6, okay, got my empirical formula, CH2O. I take the 6, I'm going to multiply across the empirical formula, okay, to get my molecular formula. So my molecular formula would be C. I've got 1 6, or 1 C, so that's 1 times 6, 6. I got 2 H's, so that would be H12, 2 times 6, and then 1 oxygen times 6, C6, H12, O6. All right, so the question asked me, find the molecular formula, or the molecular formula, so I could call that MF or whatever, molecular formula, and it said to find the empirical formula. So right there, I found both. So that's the empirical formula diagram. This one would have 1, 2, 3, 6 carbon balls. It would have 2, 3, 6, 7, 8, 9, 10, 12 carbon balls, and it would have 6 oxygen balls. 1, 2, 3, 4, 6. So if I wanted to find my molecular formula from looking here, I'd count the number of balls. I'd have 6 black ones. I'd have 12 blue ones and 6 red ones. So that would be the molecular formula diagram. Okay, guys, hopefully this helps. I'll try and do one more for you on relative mass. And that should set you up pretty well for the exam on Unit 5. And if you have any questions, I'll see you guys around. Ask me. I don't mind answering. And other than that, this is Coach Scott saying, Hullabaloo, connect, connect. Hullabaloo, connect, connect. All hail the Christian Brothers, Purple Wave. You guys have a great evening. This is Coach Scott signing out now. Bye.